Hello, Professor. Welcome to our final visual presentation for Business Operation Technology. We are Group 6 Sigma, and today we will be presenting our findings and recommendation for Crew Energy Incorporation, a leading Canadian natural gas producer. My name is Arjun, and alongside with my teammates Yash and Padmini, we will take you through our projects. So here's our quick overview of our presentation. We'll start with the overview of company, followed by the operational challenge they are facing. Then we'll explore the technological solutions that can address these challenges and present our analysis, and end with a set of recommendation solutions and implementation plan. Finally, we'll wrap up with business case study and references. So now coming to company overview, Crew Energy, an industry leader in modern vision focusing on extracting valuable liquids-rich natural gas. Their commitment to safety and significant investment in infrastructure, particularly electrification of waste symptoms area, highlights their dedication to sustainable operations and growth. Okay, now coming to operational challenges. Despite its strengths, Crew Energy faces several operational challenges such as resource restriction, dynamic well conditions, connectivity challenges, financial demands, and technological limitations. These factors contribute to decreased productivity, operational inefficiency, and heightened risks, all of the which needs and strategic management. The core issues we have identified is the scheduling problem. Ensure the right equipment and personnel are in the right place at the right time. This challenge is critical as it impacts the entire process for the exploration, production, and significant financial implications. So now coming to technological solution one. To address this challenge, we have proposed leveraging the drone technology. Drone offers an enhanced surveillance capabilities providing real-time site data for efficient monitoring and inspection. They aid in precision mapping, optimizing equipment placement, and scheduling workers, thereby reducing the risk of hazards and ensuring timely maintenance. So the next technological solutions is digital twin technology, which can revolutionize the operational efficiency by creating the virtual replicas of physical assets. This technology allows for proactive maintenance scheduling and scenario simulations. It provides invaluable insights into the performance, helping Crew Energy optimize resource allocations and reduce idle time. So now for further continuing the presentation, I would like to call my friend Padmini. Thank you.
Thank you, Arjun. Myself, Padmini. From here, I'm gonna carry forward the following slides, starting up with the technological solution 3. Our last recommendation is IoT-enabled drilling sensor and underground IoT sensor. Usually, these sensors provide real-time data and various operational parameters, and we can analyze remotely using a specialized software on computers or in cloud-based platforms. So this IoT enabled sensor has certain benefits. First, I could say is maintenance optimization is nothing but which can help in scheduling the machines for reducing the unexpected breakdowns or extending the equipment lifespan. Second will be the operational efficiency. It monitors the performance by allocating the resource, which is another most important thing. And third will be a rapid decision making, which always enables in drilling and production process. So these are the benefits I could be saying for the IoT drilling sensors. Made 3 analysis for the technologies: drone, digital, and IoT underground sensor. So in our analysis, we found that each technology offers unique benefits, whereas drone provides us quick and actionable insights, where digital will be providing a quick updates, but initially it has some complex initial setup. IoTs as well, it will definitely provide a continuous data collection and notification. Secondly, however, these technologies varies in complexity, cost, and ease of implementation. Everyone has an own advantages and disadvantages, but IoT underground sensor is even more benefitable with this easy expansion, expandable with the additional sensor, and its cost will be the another more important parameter that could helpful in implementing crew crew energy as well. So next slide will be the recommendation. So in that I would be detailing explaining why we are going with the IoT underground sensor. This slide will be the recommendation. For the final recommendation, we are suggesting for crew energy. So IoT underground sensor, this is an pictorial representation of how IoT underground sensor will be working with the drilling and operations. Like it's collecting a data and it's going to the IoT data hub, and it will be using in various purposes, user interface, analytics of business applications and backend system as well. So it has some advantages of creating a centralized data hub for better communications, and it will provide instant information, and we will be rapidly making the decisions. And it also detects the well condition alerts, operates for quick adjustment. That is an additional benefit we are suggesting for crew energy. Last will be that it's a cost effective maintenance, and it will be a perfect solution for the crew energy with those operational strategies as well. These will be the additional benefits of using IoT underground sensor in an oil and gas industries. So first will be obviously improved safety and risk management, and second will be the operational benefits, which is most important in managing the scheduling for equipments as well as workers. Third will be the environmental sustainability and regulatory compliance. Last will be the data. It can be connected with the GIC and automated system for data driven, and it has more emerging advancement innovation, which is obviously leads for more future trends. Last will be the enhanced business agility and decision making. So this approach will definitely help crew energy incrementally improves his operation while managing the cost and its complexity as well. So next will be Yash. He will be explaining about the implementation plan on the IoT underground sensor. Thank you.
Professor, my name is Gandhi, and I'm going to explain I'm going to explain the implementation plan for the to the Crew Energy Company for the IoT devices. They have, in implementation plan they have to make like the six stages of implementation plan. They in first in planning stage they have to do some kickoff meetings to plan everything, how it works and how it will work, and obtain the permits as well. The in the second stage in design stage they have to design the system and design the sensors and selection of the sensors. In the third stage, in procurement stage, after selecting the sensors, they have to procure the sensors, and they have to procure the equipment to set up the sensors. In the fourth stage, in the setup stage, they have to set up the current operations for the new upcoming sensors setup. In the fifth stage, they have to testing. They have to in the testing stage, they have to test all the sensors, and they have to do some data monitoring and optimizing things. In the sixth stage, they have to after having everything, they have to launch the sensors. After launching, they have to do real-time monitoring data, and they have to schedule predictive maintenance as well. Those are the ongoing processes, and whole the process implementation process goes through in the in approximately 10 months. After having knowledge of the implementation part, we need to discuss about how much it gonna cost initially to the company. So for the initial investment, they have to buy the sensors. So if we take the average sensor price is $1,000, then initial sensor purchase price is $50,000. Then they have to spend some money in the installation integration. It's gonna take 50,000 50 sorry 50,000. Then they have to spend some money in maintenance. It's gonna take like 15,000. Then they have to spend some more money about the data management and analytics. It's gonna take like around 30,000. The fourth one is next one is like around training and support. They have to train people for how to use the new sensors and new operations. So they have to spend some around $5,000 for that, and they have to make a new steady network of network to collecting data from all different field, which are far away from the main system. So they have to make good infrastructure, network infrastructure, and it will cost around 40,000. So they have initial cost, if we add everything, they have initial total initial investment is $190,000, and for the last four cost are the operating cost as well. So if we add that cost, the total annual operating cost is $90,000. After having initial investment cost, they have to if they implement these IoT sensors with their processes, they will get some benefits as well, some savings as well. So there are some savings, financial benefits in comparative with that. This if we assume like they have 5% increase in production, then their production revenue increased by 50. There are some saving around $50,000 over there. There are some saving in machine downtime as well. If we use the sensors, then the schedules would be good, and there are some more saving about the reduced downtime is around $400,000. The next saving is maintenance cost saving, because of the sensors, the predictive maintenance should be so good. So because of that, they have some saving over like around $20,000 per year for that as well. Then the next saving is around prevented incidents. After collecting data and after monitoring the data, they can save some emergency situations, such as a worker safety and healthy machine safety as well. So they have some savings from that as well. It's around $50,000. So in total, they can save approximately around $520,000 from the savings. So after having some potential information about the savings and their initial investment, we can calculate their ROI. So their net annual benefit is 520 minus $90,000 is around $430,000. So for calculating ROI, we need to use this formula, and we need to calculate the ROI. So the ROI by using this formula, we can calculate the ROI, and the ROI is around 126.3 percentage. So the ROI should be increased more than 100%. So it can benefit in their production, in their production system. And after having ROI, we can calculate the payback period, like after how much time they can cover their initial investment cost. For that, we can use this formula, and after using this formula, we can calculate payback period up to 4.45 years. It is approximately around 5.4 months. So after having this, after deployment of IoT sensors with the systems, they can get benefit of initial investment in less than 6 months. So it will be good, and it will be more beneficial for them, and having good operation, having good scheduling issue, resolving a scheduling issue as well. So thank you very much. We use this reference to collect all the data, and thank you very much.